Hello, Mr. Ryan, are you right? Okay. So given two input, steps and the length of the array. Okay. So what does it mean? So we are given an array with two elements, 0 index, 1 index. So basically there are two spaces. So at the beginning you are here. Okay.
I'm going to walk to 1. 2.
They are 2. Okay. So because there are 2, right? So ruler, you can think of it as a ruler. Okay. The ruler has a few, what do you call it, markers, right? So this is how many. This is determined by this. At the beginning, you are at 0.
It's not markers, it's intervals.
Intervals, okay, intervals. So 2, 0, 1. Initially, you are at 0. At one step, you can stay doing nothing. Relax, just stay, okay? Or you can walk left or walk right. Okay, so R for right, L for left, S for stay, relax.
Can
So
you stay forever?
good question. Okay, so we want to
SSS.
so we want to perform the steps. Yeah, these steps, exact steps. So we want to perform, for example, we want to perform 3 steps exactly. So the question is that how many different ways after 3 exact steps we are still at number 0. For example, the first one, you can walk right, walk left, and then stay. Then you are 0. Okay.
It's basically
Minus 1,
just-
1 and 0.
It's just basically RLS but modeled up.
That's right. Yeah. Okay. And for the third one, obviously, yeah, I can stay, and I'm still at 0.
Of course.
So for any, you can imagine, for any input, we can just keep doing staying, yeah, because we are initially we are at 0.
So 7, right?
1, 2, 3, 4. For example, RSL. So what's RSL? Right, stay, left. Okay. So there's one requirement. At any point,
You haven't got SLR.
Or you
Huh?
haven't got LSR. Dun, dun.
SLR.
LSR.
There's 7 ways, right?
And
Are there 7 ways?
SL.
Yeah, because
Okay.
there are 3 and then you could do 6 ways plus SSS.
That's very good. And I tell you what what's the other one? What's the other one? You are very good. Why is it 7?
Because there are 3, there's 6 ways of doing it.
Okay, so
plus
what?
SSS, which is 7.
Okay, so what's the missing one here?
RL, no, the
SRL.
SLR.
No, RL. No, no,
RL.
LRF.
Right? Okay. Okay, so these 3 are not. I tell you why. Because at any point you cannot cross the boundary. You cannot be here and you cannot be here. And for this one, stay left or also cross the boundary. Or this one, okay?
Isn't left. Oh.
Yeah, so at any point you cannot cross outside the boundary, which is the beyond the
So you can't-
left and beyond the
So
right.
you can't start with SL or L. L or SL at the
Okay.
start is you can't do it.
But that's very good.
And 2 R's in a row.
Yeah, okay.
2 R's in a row, no.
These 3 are invalid and we need to return 4. There are 4 valid paths. Okay. Let me give you another example. Steps. We need a 2 steps but the length could be 10. Okay. So up to 10, right? So 0 up to 9, right? Okay, up to 9. So 2 steps, and then we need to come back to 0. So how many ways? 2 steps. 2 steps. R L, right? R L, okay? And then S S. There's only 2 ways, am I right? This is a bit tricky. Why is that? Because look, these are invalid. But if we allow these, then we might perform this combination and permutation, right? We might use the counting to do it, right? Because as you said, we can muddle it up, right? So we know how many right, how many left, and how many stays. We can muddle it up and we can use the mathematics to count it. But the point is that we cannot cross the boundary, so it will be harder to do this in pure math. Make sense? Yes, because we added the 2 constraints. We can't go beyond the left and can't go beyond the right. But that's okay. So yeah, any comment before I show you the? I mean,
So you must have an R before nil. There's only 0 and 1.
That's right, yes.
So the no middle, unless you count 0 and a half.
I'm just saying you must, for that one,
Yeah.
that scenario, you must have an R before an L. If
Okay.
you want an L.
That's right,
Yes.
yes.
The L there.
Okay, so
Loser.
so we have seen similar problems before, right? Remember I can't remember the exact problem, but we know the similar process of doing this. So let's say at each position, how many choice we have? Just forget
3.
about we have 3 choice, right? So let's define a f function. So the first position will be the p. Okay, let's say we are at p. And then how many steps left? Okay, so let's say we have steps left. Okay, so this is the function. We have 3 choice. We are here. This is p, and then we need to perform the s steps. Obviously, if s equal 0, so we have finished s steps. So we need to return. We need to check if p is 0, right? Am I right? So if s is 0. If s is 0, so it means that we have finished the steps. So we need to check if p is 0. Then if p is 0, great, we find one way. If not, then we return 0. Am I right? So we can just say return p equal 0. Okay. Now let's look at this boundary thing. Here is 0, right? Here this is array length. Let's say array length air, big air.
Take the L, bro.
Okay, big air. Okay.
Why?
So, if at any point, right? If at any point p is smaller than 0
Someone.
or p is bigger than air, right? Look, if at any point we are crossing the boundary, we need to return
0.
well done, yeah, because it's invalid.
Why not -1?
No, because we are returning the number of different ways, right? We want to accumulating the number of different
Sounds
ways.
like you're gonna say a cube.
Okay. But here, look, we can add one more thing here, right? If we are at p, let's say if we are at position 10, and then we have 9 more steps, can we do it?
No.
We are at 10. We have 5 more steps to go. Can we do it? Can we reach to 0?
Stay.
No. We are at 10. And we want to come back to 0, but we only have 5 more steps to go. Can we?
No.
Why?
5 is smaller than 10.
Yeah, because even with 10 left, we can't make it to 0 in 5 steps. Right? That's very obvious, right? So if p is bigger than the step, then we also can return 0. Am I right? Make sense? Okay, so if p is on the left becomes negative or bigger than the right boundary, or p is bigger than s, if we are at p and then we have s steps to go, we can't make it to 0 because even we perform the s consecutive turning left, we can't make it to 0. That's obvious, okay? Otherwise, okay, there are three choices. So what are these 3 choices? 3 different choices. I'm at p. How many?
Stay left and right, or go right.
Sorry. Okay. So let's say the first choice is stay. Okay. So I'm going to write 1. Okay. I'm going to write 1. Every you write the second one, and Ryan you write the third one. A stay. How can I write stay? F P because they stay, right? Then how many steps to go?
Why not
S
S?
minus 1.
Why not S?
Okay. So the second choice B.
He was asking about your one, Ryan.
Okay. So B turning left. Let's say you pick one. Now this is stay, right? This is stay. I want to stay. One way stay, the p doesn't change, and then there are s minus 1 step to go because now current step.
Okay, I get it. So F, P minus 1, S minus 1.
Okay, and then your turn. C equals f.
P plus 1, S minus 1.
Well done. And then we just return.
Point.
Return A, B, C.
A or B or C. There are 3
A,
choices.
B, A.
Yes, plus.
Yes, A
Yes.
plus C. Yeah, because there are 3 choices, and we just have to add it up.
Yes.
Yeah.
Yes.
One more thing. Yeah.
Yes. Yes. Yes.
Every you're on fire today. Okay, so simple, right? This is recursion. Without the cache, this is recursion, brute force, because at each point we are brute forcing, and it could be huge, right? This is a tree. Remember, this FPS tree, and then how do you call a tree which has 3 kids? Trinary trees, right? Something like that, right? So FP minus 1.
N-ary. You mean n-ary?
Yeah,
tree?
look, this is FP.
Is it n-ary tree?
Yeah. Okay. So
And
each
like,
tree
yes!
has 3 kids, right? So, but we have repeated result, intermediate result, which can be calculated again and again. So we need to cache it. So when we cache it, it becomes a top-down dynamic programming. Top-down dynamic programming. Recursion with memoization, yeah? Or because why is it top-down? Because we want to calculate this, right? We want to calculate this. Then we are searching the tree. We are expanding the tree from top to down. But if we can calculate from the bottom up, this is bottom-up dynamic programming. And we are using the array for it instead of the recursion. Okay, make sense? But this is very straightforward, right? So FPS. So okay, can you tell me what's P, what's S? The parameters. FPS. What does this function do?
It defines P and S.
So what does P mean? What does S mean?
P means the like person and S means the steps.
That's right. P is the position of the person. S is the number of steps to go, right?
Yes!
So
Yes!
this function returns the number of different ways for the person at P with the steps to go, reaching the point 0. Okay? And then recursively, you will expand to 3 branches, 3 nodes, because there are 3 choices basically. You stay, you turn left, you turn right. Okay, and then you just sum it up. Okay, and the thing is that we need to make sure, to cut the trees when it's necessary. So we don't need to fully expand the tree, right? This could be huge, but at some point we can perform optimization by abandoning some trees. At what situation can we abandon the tree? When the person is
Back on me.
okay. When the person goes beyond the left, when the P becomes negative basically, or when the person goes beyond the right boundary, okay, or if the person at position P, and then if the step is less than P, then there's no point to continue. For example, if the person is at position 10 and the person has only 5 more steps to go, or even 9 more steps to go, then we don't need to go, because even the remaining steps turning left, it can make it back to 0 in time, right? Okay, so that's the optimization to cut off the branches. And if we have finished the steps, so if the S becomes 0, then we need to check if the P is 0, right? If the P is 0, then return 1. We found a way. Otherwise, if we finish the S step and we are not at position 0, then this is invalid. Okay? So this is the recursion with the memoization. Okay, what's the time complexity for this one? If look P and S, right? And because we're caching it, so these are known. This P at the beginning we put it 0S, right? So this P, the range of the P is the length, right? So it's actually length times S or L times S. Okay? Or L times S. Because this is the number of possible states to cache, to compute. We are caching it, okay? So what have you learned today?
Boring.
Sorry, you don't want to play games?
No.
Is that what you just said?
You're just pretending.
No, you said something.
But
Okay.
I didn't say that.
Yeah.
You're just pretending.
Okay, come on.
You're just trying to make him trying to say it, otherwise you assume that he said what you thought. You're deliberately saying something that Ryan obviously doesn't want and is a misunderstanding.
But we know how to get past you.
Okay, come on. Eric, can you summarize what have you learned today? Just quickly, 2 or 3.
2 or 3 sentences and that's it.
Yeah, come on. You
Done.
can work in the team.
We learned about the L or S, and S is staying, L is moving to the right, L is moving to the left, and you can't go past 0. And when you want to find out how much were you free, going back to 0.
I only heard the first part and the last part. Back to 0.
Okay, so you have there's a starting point, which is P, and then you.
No, we always start at 0. That's the thing. We start at 0. Yeah.
Yeah. Okay. And you have 3 options to go left, right, or rest. Smiley face.
Yeah, stay. Okay.
And there's also a boundary, like, which you cannot go past. And you try to get to 0 with us. I'm trying to find out how many possible valid ways to get to 0.
And the algorithm we're using is
Cache.
what's cache? Top-down dynamic programming. Okay.
Yeah.
Recursion with
Close
memoization.
enough.
Okay, so if this L is the length of the length, so it has to be, for example, if L equals 2, then the valid index will be 0, 1. So actually this needs to be equal, bigger or equal than L. Okay? That's it for today. Bye bye.
Bye.
Bye. Bye bye.